Hey gang, today we're going to continue simplifying non-perfect square roots. Let's do the odds together. So first one, square root of 40, and hopefully right in that number you recognize that 4 as being a perfect square. So this is going to be 4 times 10. So where possible, if you can see it, that would be great. 4 is a perfect square. We take its square root, we get 2, and we're left with square root of 10. So 2 square root 10 is equivalent to the square root of 40. And that's as simple as it's going to get because 10's only factors are 1, 10, 2, and 5, neither of which are perfect squares. Same thing for number 3. Right away, I see that 25 in the number, which gives me a hint that 25 could be the perfect square factor. And hopefully you know that 25 times 5 makes 125. We take the square root of 25, we get 5, square root 5 left over. And again, that's as simple as it gets because 5 is prime and doesn't have any perfect square factors. Okay, number 5. Now, 147, I don't really know the factors of in my head, so I'm going to go to y equals and do 147 divided by x. And I look for a perfect square factor. So I see 1 in 147 and then 3 in 49. And right away, I know 49 is a perfect square. So there's my perfect square factors. Square root 49 times 3. Square rooting 49, I get 7. Square root 3 as my answer. Same thing with number 7. I don't know the factors of 162 off my head. So I go to y equals and change it to 162. And I go down my list. I see 1 and 162, 2 and 81. 81 right away, I recognize as the largest perfect square factor that I'm going to get. So this is square root 81 times 2. Square root of 81 is 9, and I'm left with the square root of 2. Number 9, we have 320. So I go back to my table, enter in 320, and I look for a perfect square factor. So I have 1 in 320, 2 in 160, 4 and 80. 4 is a perfect square, but I want to see if there's a larger one. 5 and 64. So 64 would be my largest perfect square factor. So I'm going to write square root 64 times 5. Square root of 64 is 8, and I'm left with square root of 5. 275, I know has a factor of 25, but I want to check that there's nothing larger. So I'm going to go to y equals 275 divided by x. And I get 1 in 275, 5 in 55, and 11 in 25. So that is definitely going to be my largest perfect square factor. So we have square root 25 times 11. Square root of 25 is 5, and I'm left with radical 11. And 11 is prime, so we know we can't simplify it any further. Okay, now we've got 245, same deal. We go to y equals, change it to 245, pull up my table, look down the list for a perfect square factor. 1 and 245 is not going to work, but 5 and 49 will. So we have square root 49 times 5 gives me square root of 49, which is 7, square root 5 left over. 90 I can do in my head because it's 9 times 10. So square root 9 times 10. Taking the square root of 9, we get 3, and we're left with the square root of 10, which we know does not have a perfect square factor from other examples. And here's our last two we're going to do together before you move on to the evens. So we have some bigger numbers here. 360, though, right away, I know is 36 times 10 just by looking at the number. Square root of 36 is 6, and we're left with the square root of 10. Now, 19,704, I definitely don't know the factors of, so I go to y equals. I put in 704, pull up the table, and look for a perfect square factor. 1 in 704 doesn't work. 2 in 352 doesn't work. 4 in 176 doesn't work. 8 in 88 doesn't work. There's 11 in 64, which we know 64 is a perfect square. So 64 times 11. Take the square root of 64, we get 8, and we're left with square root 11. All right, so hopefully by now you have figured out how to do this. You're going to try the evens on your own. Check in with me so I can be sure you've got them right before moving on to your exit ticket.